Hi, it's Mrs. Swain, and today I'm going to help you learn how to do trade first subtraction. Lately, I've been getting some emails from parents with concerns about double-digit subtraction. I know I've been hearing it from a lot of kids too, and I just want to reassure you that at this point in the school year, double-digit subtraction that looks like this is expected to be doable, and most kids can. 4 minus 3 is 1, 50 minus 10, 40. Most kids can look down the column and figure that out at this point in the year. I do not expect kids to have mastered double-digit subtraction where you need to trade. That's what I'm going to help you with today. At this point, we are using a lot of manipulatives. These are base 10 blocks. One of these longs has 10 in it. In a cube, obviously the value is 1. At this point, we've used these so often this year that the kids know this is 10 without even thinking about it. And that helps us have something in front of us. It's really helpful for the kids to have something to touch and move around and help make these ideas more concrete so they can understand them. There is nothing inherently wrong with teaching kids how to do a traditional carrying algorithm. However, I've noticed that usually when second graders learn those, they're memorizing a set of steps. And when kids memorize a set of steps, they have to remember something. And it's much easier to learn a method and understand what's happening so you can make, do logical reasoning when you face a problem instead of having to have a set of steps memorized. And so when we see a problem like this in class, we make the number 62, like this. 10, 20, 30, 40, 50, 60, 6 tens, and 2 ones. Okay, now at this point, this is an easy way for me to illustrate to the kids that you can't just do 7 minus 2 like some kids try. We have 2 ones and that's that. You can't take 7 away. You're not allowed to just add more ones from your pile. You're not allowed to change numbers because you feel like it. You can, however, rearrange a number as long as it stays the same. So this is how we do it. We take one of our 10s and we know that if we break this up, it would make 10 cubes. That's what I'm going to do. I'm going to trade it for 10 cubes. Because this 10 is equal to these 10 ones, my number hasn't changed. I still have the number 62. It's just broken up into a different way. So now I can take away 3 longs, or 30, and I can take away 7 ones. That leaves me with 25. Eventually, we'll get to the point where kids can do this on paper because they understand what's actually happening. So if we have the number 31, we know we can't take away 6 ones. So I'm going to trade this 10 for 10 ones. The number's still the same, it's just rearranged. So now, since I've traded a 10, now I only have 2 10s. And since I've added 10 ones over here, instead of 1, I have 11 ones. Now I can subtract. 11 ones minus 6 ones is 5 ones. And 20 minus 10 is 10. So now I know that 31 minus 16 is 15. Now, if you would at any time like to borrow a set of these blocks to have your child practice at home, please just jot me an email or a note and I'll be happy to send some home. Sometimes kids can make them out of Cheerios or beans or other items lying around at home too. So I hope that helped. Let me know if you have any questions.